I'm going to explain you arrays in Python and using NumPy. And just before moving to NumPy, just let's have a brief introduction. That is, a NumPy stands for numerical Python, and NumPy is used for numerical computations, and it is used to create arrays, 1D array, 2D array, linear algebra, and for many other computations, NumPy library is used. And NumPy is open source library and one of the core library of Python used nowadays. It is very popular and it is used in for performing various functions related to arrays as well as 2D arrays, linear algebra, statistical computations, and so many things. So let's have a look how to how to install the NumPy library in our system. So first of all, we have to go to the location where we have installed Python in our system. So in my system, in C drive in users, I have Python in the folder inside app data, Python. Then within the Python, I'm having another folder, Python 38/32, then scripts. Now I am inside this particular folder where the Python has been installed. Now I will just install, first of all, NumPy library, NumPy module into my system. And there are some inbuilt modules, inbuilt libraries in the Python, such as math module, date time module, but NumPy library is not inbuilt library or inbuilt module of Python. We have to install it separately. And after installing the NumPy library, I will show you how to create arrays in the case of Python. And just before starting it, what we have to do, we just simply have to give a command, that is pip space install space NumPy. And this is just you have to do, and you have to make sure that Python must be installed on your system just before executing this particular command. So just you have to write pip space install space NumPy, and you just have to press enter, and it will just start installing the NumPy library on your system, as you can see, and it will just take 1 or 2 minutes maximum, and the NumPy library will be installed and you will be able to use the various functions of NumPy library or NumPy module. So as you have seen, there is a message successfully installed in NumPy. So this is the latest version of NumPy library, and it has been installed onto my system. Now I can import NumPy library on my machine and I can just use it in the programs. So just let me move to the Jupyter notebook, which I will be using to create arrays to work with NumPy in the case of Python. So as we have installed NumPy, so the very first command will be import space NumPy. So if I want to use all the functions, all the methods of NumPy library, NumPy module in my program, so first of all, I have to import this particular library, this NumPy module in my system. And arrays are better than lists in the case of Python, because arrays are faster, just because they used to store the variables in the contiguous memory location, whereas list does not have this particular property. So it is better to work with arrays. They are very fast, and arrays and 2D matrices are very commonly used in data science nowadays. So we must know how to work, how to learn with the arrays. So I'm just starting with, so this is the very first command which we have to give, that is import space the name of the library which we want to use. So we are having so many other libraries such as pandas, matplotlib, and NumPy, Seaborn, and various other libraries. So I'm just in today's video, I'm going to talk about the NumPy library, which is used mainly to deal with 1D array, 2D arrays, and there are so many interesting functions which we will see which are related with arrays. So just let me create the very first array, and the name of the array is ARR, and what we have to do exactly, we have to use a function of NumPy module, which is having the name array, and we just have to pass any list into this particular array function. So this is the syntax to create an array in the case of Python. So this is the name of the module dot the name of the function, and the array is the name of the function which is used to create array in the case of NumPy. And within the parentheses, either we can pass any list or we can pass even tuple. So just let me show you. So this has been executed successfully. So I'm just executing these cells using Shift plus Enter in the case of Jupyter Notebook. So I just want to display this particular array, which is having the name ARR. So you can see this particular array has been printed, which is having 5 elements. So if I'm going to print the type of this particular array, so you can see it is showing that it is the object is of ND array, which denotes that this particular ARR is of this particular ND array object. So in this particular way, using type function, we can see which category this particular ARR variable belongs to. So it is clearly indicating that it is an array. And similarly, we can create any other array. Suppose numpy dot array, and instead of list, now I am passing any tuple, suppose 3 elements 10, 20, 30, and now I can easily display this particular A, and now I can see even if I print the type of A, it is going to return that it is numpy.nvarray. So array is a function of NumPy module, and in this particular way, we can just create an array using the array function. Similarly, I can create a list first. Suppose 5, 4, 3, 2, 1. And after that, I can take a new variable and I can use numpy.array. And within the parentheses, I can just simply pass the name of the list, and that will be converted into array. And you can see as I have printed the value of B, now it has taken into account that an array of 5 elements have been printed. Similarly, it is not always important to have an array of integers only. I can pass float value, suppose 1.2, 3.4, 5.6. So this will also be an array. So you will see as I am going to print C, it is going to return the array. Now there are various functions which we can use with the arrays. So the very first function is ptype, which is going to return the type of the elements that particular array is having. So P is an array which consists of these 5 elements, 5, 4, 3, 2, 1, all are integers. So just let me execute it. So now it is going to return us the type of elements. So all the elements in array B are of integer type. So it is going to return int32. And if I apply this particular type function with C, now you can see in my array C, we are having 3 different numbers, 1.2, 3.4, and 5.6. So these are floating point integers, and with the floating integers, you can see that the type of the array C is float64. Similarly, we are having some other functions. If I want to see the total number of elements in my array, then I can use size function. So array name dot size, it is going to return the total number of elements. So C is having 3 elements and my array B is having 5 elements. So just let me display the total number of elements in array B. So it will be 5. Similarly, we can use various other functions such as to return the dimension. That is whether the given array is a 1D array or it is a 2D array. So we have an ending function to have the dimension of the array as our output. So all these three arrays, array A, B, and C, which I have created, are 1D arrays. So it is going to return output 1, whether I should use array B or I should use array C. Both the cases, I'm going to have the output as 1. So now just let me create a new array using numpy dot array function, and now this time I'm going to create a 2D array instead of 1D array. So the syntax will be something like this. I have to use 2 square braces, and now this particular the array which I have created using array function is a 2D array. So if I'm going to print this particular D, it is going to return me a 2D array. Now I can use another interesting function which is known as the shape. Now shape is going to return the total number of rows and columns of any 2D array. So in this particular case, the array D is having 2 rows and 3 columns, so it is going to return 2 comma 3, and it is a tuple. And if I am going to see the size, it is going to return the total number of elements in array D. So total number of elements are 6. So in this particular way, we can just create an array and 2D array, and also we can see the various functions such as the shape, the size, and the D type. And if I use ending function, now my array is a 2-dimensional array, it is a matrix. Now it is going to return the output 2, as you can see in this particular case. So these are some of the basic functions which are commonly used with arrays. Other than this, let me tell you, instead of NumPy, we generally use a very shorter name of NumPy array, that is NP. So now using as keyword, I have just renamed my NumPy library, my NumPy module to NP. And just if I execute it using Shift plus Enter, now from now onwards, if I want to create a new array using NumPy module or NumPy library instead of NumPy, I must use NP everywhere. So what particular this statement has done, it has just simply renamed NumPy to NP using as keyword. So instead of NumPy, I can just simply create, let me show you. If I'm going to use now NumPy, it will give me an error message because now it will not okay, so it is working with NumPy also, and just let me execute it. So if you are going to run this in some of the platforms, it will just going to return you an error message, because then it will not identify NumPy. It will always ask you for the NP, because now you have renamed this particular NumPy as NP. Now there are some other interesting functions. If I want to have array of zeros only, then we can use a function of NumPy module which is known as zeros. So 0 is equals to NumPy dot 0. So this is the function. So if I'm going to print this particular array, now you can see this is a 1D array of 5 elements, and all the elements are 0 inside the array. And if I'm going to print the dimension, so it is a 1D array. And in the similar manner, if I want to create a matrix of zeros, which is commonly known as null matrix, so I can use zeros function, and within the parentheses I can pass a tuple. Suppose I want to have a null matrix of 3 cross 3, and then if I'm going to display it, so it is going to give me an array of 3 cross 3, and all the elements will be 0. Similarly, I will be having another function which is known as once, and using once I can create an array of all the element which will be 1. So just let me execute it. Now you can see this is another array with the name 1, and I have used the predefined function of NumPy module, that is once, to create the array of ones. Similarly, I can create a 2D array. If I want to create a 2D array of 2 comma 4, I have to pass a tuple inside the ones function. And now if I'm going to display this particular one, so we will be having an array of 8 elements, 2 rows and 4 columns, and all the elements will be 1. And now if we want to see the dimension of 1 dot ending, it will be 1. And for 2D matrix or 2D array, it is going to return 2. So these are some of the functions. Similarly, I want to see the shape, that will be 2 comma 4, so it is going to return 2 comma 4. I can have the size, which will be 8, because total number of elements in this particular 2D array is 8. So in this particular way it works. So this was the very first method, how we can create an array. In the case of NumPy, we just simply have to use numpy.array. So array is a function of NumPy module, and within the parentheses, either we can pass any list or we can also pass the tuple. So this is the very first method to create an array in the case of NumPy using the inbuilt array function of NumPy module. Now, if I want to create an array of 100 elements, 200 elements, 1000 elements, I can't just write all the things in the list. I can't write it myself. So we are having another interesting function in the NumPy module, which is known as arange. So if you remember, in the case of loops, we used to have range function. So this is arange function is used with arrays to give a range. So just let me show you the example. So if I'm going to print this particular arange, now what this arange will do, if I have passed only one parameter, that is 10, it is going to give output an array of 10 elements starting from 0 up to 10 minus 1, that is from 0 to 9, an array will be created. Similarly, let me show you some other interesting example using arange function. If I want to print an array from 50 to 100, I can pass this particular syntax. And if I'm going to display this array 1, so using arange function, now I have passed 2 different parameters. So this is the starting value of my array, and the array will end at 1 less than the value in the second parameter. So 101 minus 1, so up to 100, this particular array will work. And I can also pass the third parameter in the arange function. If I want to display, suppose, only the even numbers from 50 to 100, then I can use this particular syntax. So if I'm going to display array 2, you can see it will just only display 50, 52, 54 up to 100. So now this 2 is working as a step size. So after 50, it will just take a step of 2 and it will move on to 52. It will just skip 51. Similarly, the array will work in the same manner. Similarly, we can just, if I want to print any array of my choice, suppose I want to display from 1000 to suppose 0, and I can even give the negative indexing, and this particular array is going to display an array message. Okay, so I have mistakenly give the name wrong. So arange function, and from 1000 to 0. Now if I'm going to display this, you can see this array starts from 1000, it will go up to 1 element less than 0, so that will be 5 in this particular case, because now I'm going to decrement my step by 5 every time. So the starting element of the array will be 0, then 995, 990 up to 20, 15, 10 and 5. So in this particular way, we can just generate, suppose I want to have an array of my choice from 11 to 20, suppose I want to display. So I will just simply give 11 comma 21, and if I will display this particular array with the name array 4, now you can see we will be having an array from starting from 11 and ending up to 21 minus 1, that is 20. So this is the second method, which provides us a lot of flexibility regarding array generation. So the very first method was array function, array method of NumPy module, and the second important function is arange function, which works only with arrays, and it is going to return as array according to the parameters, according to the values which we are going to specify in our case. And using this particular arange function, we can interestingly convert any array into a 2D array. So just let's see the syntax. So if I'm going to create a matrix, I have taken the name mat and np.arange. Now this particular np.arange 12 is going to return an array of 1D array of 12 elements from 0 to 11. Now if I want to convert it into 2D array, then I can use in p.arange12, then dot, then there is an interesting function reshape, which is used to convert any 1D array into any other dimension. So if I'm going to use 4, 3, so now it will convert this particular 1D array into 2D array of dimension 4, 3. So now you can see the elements will be automatically arranged as according 4 rows and 3 columns will be there. Similarly, if I want to give any other dimension, suppose in p dot arange 12 dot reshape, and this time suppose suppose if I just give 3, 3, now there will be an error message because my original array mat contains 12 elements and it cannot be divided into 3, 3 because 3, 3 will be having 9 elements. So you can see the error message. We cannot reshape array of size 12 into shape 3, 3. So what we have to remember, we always have to give in the reshape parameter such that it must be a multiple of the number which we are going to use. So either I can use 2, 6 or 6, 2 or 3, 4 or 4, 3. And I hope it is clear to all of you. Now I'm going to display this mat2. So it will just rearrange or reshape my original matrix, 1D array matrix into 2D matrix of the size 2, 6. Now you can see it has converted these 12 elements from 0 to 11 into a shape of 2, 6, and even I can use the size function. So the size is going to return the total number of elements in the array, and similarly if I want to see the shape now, so the shape is going to return it is going to return a tuple. So the first parameter is total number of rows and the second is the total number of columns. So in this particular way you can convert any 1D array. So just let me take one more example. So if I'm going to take an array of suppose 10 element, and now I can convert it into suppose 5, 2. So mat3, so 0 to 9 elements will be arranged into 5 rows and 2 columns, and similarly you can see the dimension using ndim function, and ndim function is going to return you 2 because now it has converted into a 2D array. So this is all about arange function, and 2 more functions are there that is I'm going to discuss. The very first is linspace function, which is used along with the NumPy module. So np.linspace, and if I'm going to pass suppose 0, 10, 5, and just let me execute it. So it is also going to return an array. And now what are these parameters? This is the thing which we have to understand. So the very first parameter is the starting and number of that array, and this number is the last number of that particular array, and 5 means total 5 elements will be created in the array, and this linear space function is going to return an array in such a manner that the elements are equally dedicated, allocated. So there will be a difference 2.5 and 5 minus 2.5, it is 2.5, 7 minus 7.5 minus 5 will be 2.5. So they are linearly spaced within the array, and these two parameters indicates the starting and the last number of the array, and 5 will be the total number of elements which will be in the array, including these 2, 0 and 10. So in this particular way we can just have anything we want to do with our linspace function. So suppose from 1 to 10, I want to give 4 numbers which are linearly spaced. So I can just execute it using shift enter, and if I just execute this particular cell, now you can see from 1 to 10, I want 4 integers, 4 numbers inside my array that should be linearly spaced. Now you can see starting from 1 and last number is 10, and we require 2 more numbers inside this array, and they should be linearly spaced. So if you are going to check the difference between the consecutive values, that is 1 and 4 is 3, 4 and 7 is 3, and 7 and 10 is again 3. So in this particular way, the linear space function is going to return us an array. And the last function which I'm going to discuss in today's video for creation of array is the random function. So let me take a variable ran, and in the NumPy module, we are having another module random. And within that random module, we are having a function with the name random. Now I have passed a value 5, so just let me display the value of this ran. So you can see np.random.random. Now this np is NumPy module, and within the NumPy module, we are having another module with the name random, which deals with random numbers. And within this random module, we are again having a function with the same name, with the name random. And if I have passed only one integer 5, so it is going to return me an array of random numbers, and the value of random numbers will lie in between 0 and 1. So you can see all these values are inside the range, are in the range of 0 and 1. And even if I want to create a 2D array, I can just simply pass a tuple inside the random function, suppose 3, 4, and if I'm going to display this ran1 array, now you can see I just have a 2D array, a matrix of random numbers of dimension 3, 4, and all these numbers are in the range of 0 to 1. And if I want to check the dimension of this ran1, so I can use array name dot ending, so it will be 2, but if in the case of ran, which I have treated as 1D array, it will be 1. Similarly, if I want to see the size, that is the total number in the case of ran2 array, so it will okay, so it was ran1. So if I'm going to have the size, it is going to return the total number of elements, which will be 3 into 4. And similarly, if I want to see the total number of elements in ran arrays, that will be 5. And similarly, we can also see the shape, as I have already discussed. So these are some of the functions which are used most commonly in the case of arrays. So if I'm going to use dtype to have the type of elements, so the elements are of floating type numbers in the ran1 array. And similarly, if I will use this dtype with ran, it is also going to return the float, because we are going to have a random numbers in between 0 to 1, so they can be fractional also. So this is the very first introductory lecture of how to create an array. So I'm just summarizing the thing. So first of all, we have to install the NumPy library by going into the command prompt and going to the exact path where our Python is installed. Then once NumPy is installed, you can just move on to any of the platforms such as Jupyter Notebook, Spider, Anaconda, Visual Studio, or even you can just simply use simple Python shell to execute the NumPy programs. So the very first command is we have to use NumPy using import. Then we are having some predefined functions inside this particular NumPy module. The very first function is array function. Within the array function, either we can pass list or we can pass tuples, and we see various functions, size functions, ending functions, shape function, and dtype functions, which are most commonly used. And it is a very common practice to use rewrite NumPy as NP. So in this particular manner, instead of NumPy, we will be using NP dot the name of the function which we want to access. We can have an array of zeros using zeros function. We can have an array of ones, which is known as unit matrix, using ones function. And after that, I have explained you a very interesting function which provides us flexibility to create an array of any pattern. So a range function, we can use it totally works similarly, just like the range function which we used to have in the loops used with for loop. And we can even pass the third parameter as negative integer. The array will be printed in the reverse manner, as you can see, and it's totally our choice which range we want to print using a range function. And then I can easily convert any 1D array into 2D array using dot reshape function. So reshape function will just convert any 1D array into any 2D, 3D, or any ND array. So we just have to be careful. This parameter should be the multiple of the number which we are going to provide here. Otherwise, we will be getting error, as you can see. And in the end, I have just shown you two more functions. First is the linspace. And in the linspace, we are going to pass three parameters, and it is going to return the linearly spaced numbers inside the arrays. And random function we can use, and the random function is there inside the random module, and the random module is there inside the NumPy module. So np.random.random, this particular random is a module name, and this particular random is a function name. And if I'm going to pass only one value, so it is going to return me a 1D array of 5 random numbers. And if I'm going to pass a tuple inside this function, so it is going to return a 2D array or a matrix. So I hope I am clear to all of you. And in the next video, I'm going to discuss basic operations on arrays, how we can perform addition, multiplication, subtraction, matrix multiplication, and we will also see some of the various aggregate functions, such as sum of array elements, then mean of the array elements, and minimum or maximum of the array elements. So all these interesting things we will see in our next lecture. So I hope this lecture finds interesting to you, as well as very useful, especially those who are working with Python and the arrays in Python. So I'm stopping here, and in the next video I will just discuss about various basic operations with arrays and matrices. Thank you.